I love any opportunity that I can have to understand the quantum world better. And how cool is that to pair it with technology that people care about, like a very powerful artificial intelligence compatible with quantum computers. I grew up in Richmond, Virginia. I did not really know what I wanted to do for a long time. Actually, when I was a kid, I think like many kids, I wanted to do everything. Oh, that sounds fun, that sounds fun, that sounds fun. So when I went to college, I was taking a bunch of science prereq classes, like the foundational stuff, just trying to get a better sense of what I might enjoy. But in that journey, I had to take the calculus sequence, calculus 1, 2, and 3. I will tell you, I don't have any memories from Calc 1 or 2. Somehow I managed to pass. And I think it was just rote memorization. And this is what I thought math was. But when I got to calculus 3, I had an amazing teacher that kind of changed everything for me. So he really taught math as these concepts and ideas that anyone can grasp, not just people with elite genius DNA, or the math gene, they sometimes call it. But anyone can have access to the ideas if they're explained well enough. And so he would teach math in that way, and then also make connections to the world around us. And it's like my eyes were opened. And so after that, I realized I wanted to study physics, actually. I was really fascinated by the world we can't see, the quantum world. And I started to learn that there's some mysteries in physics that are unsolved to this day. And to me, and I think to many, young people, that's fascinating because you're like, wow, maybe I can have a shot at that. And I was just really kind of blown away by this idea that there is profundity in simplicity. Because if you can ask the right questions that are profound, that can unlock everything. My first introduction to AI, and I'm specifically thinking of language models, which is what, a lot of people think when we say AI, was around 2016 or so. So my advisor and some of his colleagues had this really cool insight. Language is kind of like a quantum system because language involves little tiny things called words or letters or tokens. And they come together according to some statistics in a language to create a coherent, cohesive whole, namely meaning and semantics and information exchange. Well, that's interesting because, in the world around us, you have these little tiny pieces called atoms and molecules, and they come together according to some statistics governed by nature to create things like a table or a chair. So wouldn't that be interesting if we open some of these tools in the physicist's toolbox and try to apply them to language and maybe build something that helps us understand how language works from a mathematical perspective with an eye towards application? A year or so after that, GPT-1 comes out, GPT-2, ChatGPT, whatever. Now all of a sudden the research that I'm doing is attractive to mathematicians, and because now I'm kind of in this bridge between the AI machine learning world, which I had an opportunity to learn that was very new for me at a time when it's booming. And then this community of mathematicians who are like, wait, what's going on in AI? When I got into graduate school, I would start to write little expositions to myself, trying to describe these sort of lofty ideas in easy to understand ways that are bite-sized for me. And I just wrote a blog article to myself, trying to make sense of something called tensor networks, which are sort of useful ways that mathematicians and physicists can work with high-dimensional data. Little did I know, there is a team at Alphabet who just the week prior released an open-source library on exactly the same thing. So they have the similar idea of taking ideas and trying to sort of democratize them and make them useful for anyone. I also didn't know they were reading my blog. So I get an email from the team, and they said, oh, we really enjoy your writing. We're working on something similar, let's stay in touch. The long story short is I ended up getting a postdoc with the team after my PhD to work on these ideas, this sort of tensor network, language modeling. The tensor network tools now are used for SandboxAQ's AI simulation team. So simulation optimization of drug discovery. That's just one of the toolbox they use. So I think that's really cool because this sort of love of science communication and writing about complex ideas in easy to understand ways for the public was a shared priority between myself and Sandbox. One thing I really enjoy about the EDU team, the education team at Sandbox, is that we are aware and embrace the idea that SandboxAQ's technology is so cool, grounded in firm, real science, but not everyone has a science background or education. And I think one thing that's really encouraging is just for the public to know that there's so many different ways that one can enter into science and tech. And I just think that that sort of diversity and variety of stories is something that's really cool to capture. So one thing I'm excited to do in the future is to have more conversations, even with friends and partners of Sandbox, to hear their stories, to hear some of the cool technologies and science ideas that they're working on, and to make that available to the public. So kind of taking that science communication idea for technical ideas and now translating it to the story and the human aspect. My name is Tai-Danae Bradley, and I work at Sandbox AQ, finding ways to connect pure mathematics to the world around us.